Dear participants, thank you for waiting. We'd now like to start 5G Special Day 5, Latest Trends 2023 International Workshop, International Trends in Millimeter Wave Introduction, Issues and Future Prospects for Millimeter Wave Utilization. Today, simultaneous translation service is available. If you wish to listen to the translation, please use the receivers handed out at the reception desk. Channel 1 is in Japanese, Channel 2 is English. My name is Yu Maki, and I'll be your moderator today. To open the symposium, we'd like to ask Dr. Yoshida Susumu, Chair of the 5th Generation Mobile Communications Promotion Forum, Professor Emeritus of Kyoto University, on behalf of the organizer of this workshop, to say a few words. Please welcome Dr. Yoshida. Dear participants, thank you very much for your introduction. I am Yoshida, Chair of the 5th Generation Mobile Communications Promotion Forum. On behalf of the organizers of the 5G Special Day 5 Trends of 2023 International Workshop, I'd like to say a few words. Please forgive me if some of my remarks have been already mentioned in my morning address. First, allow me to extend my sincere appreciation to all of you who have gathered here today in this venue and those who are participating online. My special thanks go to all the lecturers, panelists, and moderators who kindly agreed to speak at this international workshop out of their busy schedules. I'd also like to express my sincere gratitude to all those who have contributed a great deal in holding the conference at this Makuhari venue for the first time in 4 years. In the environment surrounding 5G and local 5G, various efforts are being made to further accelerate its penetration and deployment for its further use for the society, and also in preparation for Beyond 5G Ready Showcase exhibition at the Osaka Kansai Expo in 2025. As has been discussed by the General Manager Ogiwara, to promote the digital garden city concept promoted by the Kishida administration, the Ministry of Internal Affairs and Communications formulated the Digital Garden City Infrastructure Development Plan in March last year, and its revised version was introduced this past April, which clearly states that the diffusion and deployment of 5G networks shall be accelerated to realize a world top-class 5G environment. The plan also emphasizes the need for initiatives related to the beyond 5G priority technology areas. And as has been covered as the theme for the workshop in the morning, local 5G is also positioned as an important infrastructure to solve regional issues, and institutions and systems have been put in place based on the development and demonstration projects that were conducted until last fiscal year. On the other hand, as has been reported in the past, 5G-MF is actively engaged in activities to further promote the penetration of 5G and local 5G. As an example, on the 5G-MF website, we have published a 5G and local 5G case study map to allow viewers to have a glance at where and how unique 5G cases are seen in Japan. Many people are pinning high hopes on this, but unfortunately, we have to say that it has not progressed sufficiently in terms of coverage area and the number of terminals. To deal with this situation, in January, we launched the millimeter wave promotion ad hoc targeting the acceleration of 28 GHz band millimeter wave deployment, and published the first edition of the white paper in March and second edition in July. The paper contains valuable insights such as use cases and references to the affinity between local 5G and millimeter wave, in addition to a detailed analysis of various issues for millimeter wave deployment. We'd like you to take a look at it. We also held some events. One is a workshop held in Tokyo in the May jointly with 5G ACIA, a German-based organization working on 5G deployment in the manufacturing industry, including the use of millimeter wave. Japanese companies also participated in the discussions, including the use of millimeter waves. The details of these activities that I mentioned are all available on our website. Today's 5G Special Day 5 Trends, Latest Trends 2023 International Workshop is to be held jointly by the Ministry of Internal Affairs and Communications, 5GMF, and the Association of Radio Industries and Businesses. This year, we focus on millimeter wave, and in the first half of the workshop, following the keynote speech by Mr. Ogawa, Director of Mobile Communications Division, MIC, 4 experts from overseas and 2 from Japan will introduce the latest trends and millimeter wave initiatives in their regions and organizations. In the latter half of the session, we will have a panel discussion moderated by Mr. Waichi Sekiguchi, President the Millimeter Research Institute, inviting the experts who will have given lectures as panelists to boldly look into the future and discuss the contribution to digital transformation that will be brought about by millimeter wave and innovation. We sincerely hope that today's workshop will provide useful input to promote utilization of millimeter waves, and that it will be conducive to the early deployment, diffusion, and deployment of unique services. As was mentioned in the morning address, the 5GMF per se will end its 9.5-year activities at the end of March next year and will evolve into a new forum integrated with the Beyond 5G activities from April. We are very happy to report to you that we have been able to co-host the 5G International Workshop with the Ministry of Internal Affairs and Communications as many as 8 times in the CEATEC. I'd like to take this opportunity to once again express my sincerest gratitude for the cooperation and support you have given to us. With this, I end my remarks. Thank you very much.
Professor Yoshida, Chair, thank you very much. Next, we will have the keynote speech. From Ministry of Internal Affairs and Communications, we have the Director of Land Mobile Communications Division of the Radio Department Telecommunications Bureau, Mr. Ogawa. Mr. Ogawa Hiroyuki, please. Good afternoon, and thank you for the introduction. I'm the Director of Land Mobile Communications Division at the MIC. My name is Ogawa. I'd like to talk about 5G trends, mainly the situation in Japan. Here we look at the history leading to now. 5G. There were many years accumulation of R&D based on the technological development. As you see at the bottom where it says technology, from fiscal 2017 for 3 years, there were the 5G comprehensive experiments. So development and demonstration was conducted. And based on that, you see at the top, spectrum allocation was conducted 2019, April. So spectrum for 5G was allocated toward the commercial service start of 5G. Commercial service started in March 2020, and after that there was the Tokyo Olympics and Paralympic Games, and toward those events the objective was to spread the service nationwide, and that work has continued. And then in terms of additional frequency allocation for 5G and local 5G institutionalization and promotion, and also comprehensive experiments have also been promoted. And based on that, as of now, 5G population coverage ratio has reached 95%. Well, the target was 95% in fiscal 2023. That was achieved 1 year earlier. Was 96.6% in end of fiscal 2022. MIC based on the infrastructure development plan of the digital garden city concept. We are aiming for 99% achievement by fiscal 2030. As you see at the bottom, toward the future for the next generation network beyond 5G and 6G, we are accelerating the R&D toward those next generation technologies. So 5G infrastructure service introduction has been progressing. However, it's been mentioned recently that 5G related infrastructure development and device terminals and use cases are all in a chicken and egg relationship. And people saying that the business has not progressed sufficiently. So you see the infrastructure at the top. So incentive to invest in infrastructure development is lacking. That's because number of devices and use case are limited. That's leading to the limited infrastructure development, some say. But from the view of the terminal side, well, terminals are not disseminating, cost still high. That's because the usable area is limited and use cases are also limited. So that's been pointed out. And then from the use case perspective, use cases are not sufficiently created. That's because the usable area is limited and the terminals that are compatible with the new technology are limited. So overall, there is the chicken and egg relationship amongst these three factors. So infrastructure, a terminal, use case. Let me look at the situation for each. First, about the infrastructure. As you know, the number of cell phone subscribers per inhabitants in Japan is the highest in the world. And the number of subscriptions total continues to increase year after year. Now looking at the traffic increase is continuing. Recently, 1.3 times per year we're seeing increase in traffic. In terms of the traffic increase, in order to deal with that, we need to use the high frequency millimeter wave and further promote 5G. And also, in terms of 5G frequency allocation status, in Japan, we have in 2019 sub-6 and millimeter wave allocated for wide bands. And in various countries, various spectrum has been allocated. Mainly the mid-band use is progressing, so allocation has been progressing there, but for millimeter wave, it varies by country. As for the base stations situation, so 5G base station development is rapidly spreading in various countries, especially millimeter wave base station. Japan has the second highest penetration after the United States. On the right-hand side, the horizontal axis is population coverage. A vertical axis is the share of 5G in total traffic. You can see that the lower right, you see Japan. So various countries have relatively high population coverage, but the 5G traffic percentage is relatively low. This is consistent amongst various countries. Looking at the terminal side, in the US, the percentage of millimeter wave compatible devices is 64.7%, quite a high rate. In Japan, on the other hand, it's only 2.4%. Now, iPhone series which has a relatively high market share in Japan, doesn't support the millimeter wave. I think that's one of the reasons. And so we need to increase the compatibility of the terminals to 5G. Looking at the actual user experience, you see this graph, orange line is 5G population coverage rate in various countries. The lower blue line is percentage of users who feel connected to 5G. Far left is Japan. So population coverage rate is high, but users can't really feel that they're connected to 5G. So there is that big gap between these two figures. That is the unique state of affairs in Japan. Now, consumer expectations for 5G. Consumers looking for speed, coverage area, and communication stability. So those are the areas where they are looking for further improvements. And for that, they are willing to pay additional amount. That is what this questionnaire survey shows. So 2 parts to each graph. So those who doesn't have the experience of using 5G and those who feel that they have 5G experience. So we've broken down into 2, looking at how much more they're willing to spend. So those who feel that they have the 5G experience, they are willing to pay more, pay additional sums, larger additional sums compared to those who have not felt the experience of 5G. And this is something we need to keep in mind. Also, corporate expectations for 5G, high speed, large capacity, and security being ensured, those are the points that are high on the list of importance. So small coverage, transmission speed, and cost are areas where they feel that the required level has not been achieved. So based on this kind of analysis, at MIC, we have put together the 5G Business Design Action Plan, a list of policies and initiatives to be taken by the MIC. I will not go into, and I don't have the time to go into the details of this, but there are 3 factors which I referred to earlier: infrastructure development, use case creation, and popularization of devices and terminals. And so we're trying to solve the chicken and egg problem from these 3 perspectives, make improvements, and move forward. That is what we like to achieve with this. That has been a brief introduction from myself. I thank you very much for your attention.
Thank you very much, Mr. Ogawa. Now, without any further ado, we'd like to go straight into the session 1. The first speaker in the session 1 is overview of millimeter wave promotion ad hoc white paper. We will have 6 speakers in this session. The first speaker is Mr. Nakamura Takehiro, the 5th Generation Mobile Communications Promotion Forum, Millimeter Wave Promotion Ad Hoc. He will give us the overview of the millimeter wave promotion. Mr. Nakamura will participate online.
My presentation? Sure, should be okay. Okay, yeah, thank you very much for inviting me to this interesting and excellent events on the millimeter wave. Today, I would like to provide my presentation on the white paper of the 5G MF millimeter wave promotion ad hoc. Actually, I'm working for NTT DOCOMO, but I would like to provide my presentation as a chair of the millimeter wave promotion ad hoc of 5G MF today. Okay, next slide, please. Okay, so this is outline of our ad hoc, and actually we established this ad hoc in January this year, and currently 29 companies are joining, and 2 observers, and yes, 59 members now joining this ad hoc. And we have already conducted several kinds of the important activities, as you can see in this slide. We published white papers and also promotion activities in the several kinds of the exhibition. And yeah, okay, yeah, please go to the next slide. And this is overviews of our white paper. Actually, in the ad hoc, we studied and analyzed the millimeter wave situation very in detail, and summarized our study results in our white paper, as you can see. And we covered a variety of the topics, and including the necessity, need, and trend, challenges, and technology, performance, and introduction scenarios, and also affinity with local 5G, use cases, and existing solutions for the millimeter wave, and also business outlook. I'd like to explain each of the chapter after this slides briefly. Next slides, please. And first, this is a need for the millimeter wave. We try to clarify the needs. And yeah, actually, we identify the needs, as you can see, securing the frequency resources for the future traffic increase. Yes, maybe not only Japan, all over the world, mobile traffic is increasing steadily, maybe around 1.3 to 1.4 or something times per year. And maybe we need more spectrum resources for the future, and the support for the future high-speed, large-capacity, low-latency services, and the economy, energy efficiency, developing new use cases, and a foothold for the additional frequency allocation in the future. Next, please. And this slide shows the trend in Japan and overseas. Actually, while the 5G services are progressing, as Ogawa-san explained, all over the world, and use cases of the millimeter wave remains limited despite the progress in frequency allocation. And trend in the millimeter wave in Japan and overseas are summarized. So you can see here. Actually, please look at our white paper in detail, but we summarize the trend the point on the frequency allocation commencement status of the millimeter wave commercial services, and the status of millimeter wave terminals, and the 3GPP standardization trend. Okay, next, please. And this slide shows the challenges for the widespread use of the millimeter wave. Yeah, actually, Ogawa-san, as Ogawa-san mentioned, that we have a chicken and egg situation in terms of the area, base station, terminal, and use cases, as you can see in the right bottom figure. And but we have several kinds of the challenges, as you can see. Yeah, so maybe, yeah, that should be now on. Okay, so anyway, we have several kinds of challenges due to the characteristics of the millimeter wave. So we need to solve this kind of challenges to spread the millimeter wave. Next, please. On the other hand, the many kinds of the millimeter wave technologies has already developed and deployed, and will come in near future. So this slide shows many kinds of the technologies such as the beamforming technologies, MIMO technologies, topology improvement technologies, and so on. So in any case, we have many technologies to improve the millimeter wave performance and the coverage, as you can see. So we should use this kind of technologies more and more, to deploy the millimeter wave, to spread the millimeter wave. Next, please. And also, we analyzed the performance evaluations and summarized in our white paper. Actually, millimeter wave has already deployed commercially, and we summarized some of the measurement result in the commercial deployments. And as you can see, for example, left figure, this is the indoor measurement case. And as you can see, the very high throughput, more than 1 gigabps, 1000 megabps, close to the 2000 megabps indoor case. And also outdoor walking measurement, as you can see in the right-hand side. And again, even in the outdoor, the millimeter wave performance is very high compared with the sub-6 or LTE. Yes. Next, please. And this slide shows introduction scenarios we considered. Actually, we are deploying many kinds of the spectrum bands already. And but maybe, as you can see in the right top figure, we can deploy the low band, mid band, millimeter waves, case by case basis. Especially for the coverage, low band should be good, of course, but the performance is not so good in the low band due to the limited spectrum band width. Mid band, yes, maybe coverage, performance, both should be good. And but especially millimeter wave, of course, we have some difficulty to extend the coverage drastically by the millimeter wave, but the performance is very high. So considering this kind of the characteristics of the spectrum bands, we should deploy case by case basis. Especially millimeter wave, that is good to deploy for the limited area, but high performance is required, such as hotspot, stadium, event venues, office, indoor, private network, local 5G, urban sidewalks, road and intersections, and FWA. Next, please. And also, we see that we have a very high, good affinity with the local 5G, private 5G network. And yes, considering the millimeter wave characteristics such as the limited area and high performance, maybe local 5G private network use cases are very similar situations, limited area, but the high performance is required in the private network local 5G. So in that sense, millimeter wave is very good to use, to be used for the local 5G private network use cases, as you can see. Yeah. Next, please. And also, we can consider the variety of the use cases of the millimeter wave. And yes, we show that some of the typical use cases we think to be used for the millimeter wave area. For the EMBB case, maybe increase the capacity is important. And actually, NFL finals use cases that has already deployed in the US market, and some kind of the sports event to accommodate a very high capacity. And FTTH, fiber to the home, alternatives with the FWA, fixed wireless access. This is also very one of the typical use cases, and especially in the world, FWA is a very good use cases of the millimeter wave, we believe. Yeah, even in Japan, the optical fiber can be used so widely. But even in Japan, we have a good use cases of the fixed wireless access, and most of the operators, MNOs, provided services of the FWA. And that is very we are providing the very good performance by the FWA. And enterprise networks, and especially for the enterprise business, maybe they need a very high performance, and the millimeter wave should be good to deploy for their use cases of the enterprise network. Okay, next please. And also we summarize the existing solutions of the millimeter wave. As you can see, we already have a variety of the solutions of the millimeter wave already, as you can see. And there are many of the base station companies and measurement companies and other equipment companies provided the millimeter wave solutions, as you can see. So we can use this kind of the solutions already. And so in that sense, we are ready to deploy the millimeter wave more. Yeah. So new solutions will come. More new solutions will come. So I hope that we can use those kind of solutions with the cost-effective manner. Yes, to spread the millimeter wave. Next, please. And business outlook. So we showed solutions or use cases or many kind of the topics on the millimeter wave. But it is important to consider how to create the business by the millimeter wave. So we are still discussing on this topic, but we summarize some of the idea for the business success of the business in terms of the area development and promoting and supporting 5G millimeter wave to other industries and providing the place to promote the spread of the millimeter wave and 5G wireless human resource development. We need to study and consider these kind of topics more deeply. And also, of course, we can consider the other, we can find other ideas to spread the millimeter wave for the business use. So, we will continue such kind of the studies for the spread, success of the business by the millimeter wave. Okay, next, please. Okay, so this is conclusion. And we have already published the millimeter wave white paper, version 2.0. And we will continue the activities to promote the millimeter wave in Japan and also overseas, including promotion of the contents of the white paper. Okay. Yeah, thank you very much for your attention.
Mr. Nakamura, thank you very much. Next, from South Korea, Dankook University, we have Dr. Lee Hyung-woo going to talk about 5G status and preparation for B5G in Korea. Professor Lee Hyung-woo, please.
Thank you, Professor Yoshida and 5GMF for inviting me to this valuable session. My name is Lee Hyun-woo, professor, but I'm also serving as a vice chairman in 60 forum in Korea, responsible for international relationship. As well as in Korean Standard Body TTA, I'm responsible by chairman of mobile committee. So today I will show you two parts. First one is the 5G status in Korea, and second part is in beyond 5G preparations. So this simple graph showing that mobile subscription in Korea, in general, mobile penetration ratio is 156%, a little bit lower than Japan. However, in terms of 5G, we have 31 million private subscription. That stands for roughly 40% of mobile subscriptions. This is achieved 4.5 years of commercial service start in April 2019. Right graph is my mistake. So that I show you the penetration ratio 5G. But the important thing is in the mobile traffic. So in Korea now the 5G handles more than 80% of the mobile traffic, and the average 5G user per month is roughly 29 gigabytes, while 4G LTE handles around 18% of mobile traffic, and 4G subscribers usually use around 8 gigabytes per month. So that means that the 5G subscriber consumes more than 4 times of the 4G subscriber. Actually, the 5G tariff is a little bit higher than 4G, roughly 20% or 30% higher, but they consume 3 or 4 times mobile traffic than 4G. So this is maybe good for the mobile operators. So in average, the Korean mobile subscriber use around 17 gigabytes per month. This spectrum, actually, the Korean government issued a license in 3.5 gigahertz as well as 28 gigahertz. And currently, 3 mobile operators all have 100 megahertz per operator. Currently, we started from non-standalone mode, but now the operators gradually upgrade to standalone mode, especially the leading operator, Korea Telecom, deployed the network almost nationwide with standalone. And other 2 operators following and will follow, and still transition stage between NSA and standalone mode. Actually, even though we started with deploy millimeter wave deploy network, but the progress is slower than expectation, so the government decided to terminate the license because initial license until next year, but government decided to terminate the license a little bit earlier because the deployment was slower than expectation. However, initially the condition, millimeter wave condition is to deploy the network nationwide. However, we found that the network deploying cost is higher than mid-band, so it was delayed. So now the government new policy is to allow a regional coverage for millimeter data. For example, in Seoul area or Busan area or Daejeon area, that will be allowed for new mobile operators. According to current plan, maybe end of this year or early next year, new operator decision can be made. The spectrum allocation is in the bottom of the graph. However, in private 5G, still we use both mid-band and higher band, around 29 gigahertz band. Similar to local 5G in Japan, in Korea we also have a private 5G. We call it EOM 5G. So EOM came from the word EMMB, URLLC, MMTC. So end of July, we have around 23 organizations for 39 locations for local 5G. This morning, I heard that several deployment in Japan, in power company and highway company, and the small company for backing. Yeah. And similar to Japan, we have several applications, including mobile robot or AI vision for defect monitoring, the production line digitalization, and safety management, etc. So there are several applications deployed. Even though in terms of population coverage, we have more than 96%, however, in Korea, maybe similar in Japan, the 70% of Korean territory is a mountain area, so still geographical coverage is not sufficient. So we are doing network sharing in rural areas, like mountainous areas or remote coastal areas. So the three operators are sharing their reduced network in rural areas, and that's ongoing very well. And we have planned to complete the network sharing in remote area by first half next year. There are two options for network sharing, MO-RAN or MOCN, but in Korea we adopted the MOCN approach. The MOCN approach is that CONNET is different per operator, but the radio access network can be shared by three operators with one frequency. Okay, second part is the beyond 5G preparations. So we already started for beyond 5G or 6G core technology research from year 2021. It's already ongoing with 5 years investing around $200 million. That is the 5G, 6G core tech research. And recently, the Korean government approved the second phase or 6G system research starting from next year for 5 years until 2028. So around $300 million will be invested for this system research. Additional preparation is ongoing for 6G low Earth orbit research. That is under preparations. Maybe early next year, there will be some decision on goes or no go for this low Earth orbit satellite. If adopted, the project will start from 2025 until 2031 for 7 years with around $400 million. So if 3 project goes well, we can have a total solution from terrestrial network to satellite network with 6G. As you know that there's new vision for 6G, some features from enhancement of 5G, and some feature is a new feature for 6G. For example, integrated sensing communication or integrated AI in communication is a new features, while immersive communication, massive communication, reliable communication are some enhancement of 5G. So for that new features, we have some focusing area for 6G system research. 2 directions is for radio communication innovation and software-based network. So these are the 2 directions. And we have 3 missions to realize the beyond communication. That means including the computing and sensing with communication. And second part is energy efficient technology, using AI functions or high efficiency and low power device, something like that. And third one is the supply chain securing. Recently, we had some problem in global supply chain because of some countries' political decision. So For that to compensate the kind of situation, we will develop a key component in terminal or base station, including optical transmission device. So if it goes well, we can have a pre-6G demo on end of 2026, and we can start 6G service around 28 to 2030. For that purpose, we are doing several international collaborations with the USA, China, and Finland. And for promotion, we have MOU with Europe and USA. And we are now discussing with Japan, B5G-PC, to set up some kind of collaboration. In addition to that, we are doing several collaboration with first tier or second tier country, because in 6 areas, the pre-standard collaboration is more important. So that is the end of my presentation. Thank you.
Thank you very much, Dr. Lee Hyun. Next, we'd like to invite Mr. Osuke Koiman from the Qualcomm. He will speak about 5G advanced milliwave opportunities and challenges. Mr. Koiman, please take the floor.
It's a pleasure to be here. I want to thank the organizers for inviting me to Japan. My name is Osuke Koiman. I'm part of Qualcomm Research. I've been leading the millimeter wave effort in Qualcomm for the last 8 to 9 years. So that's the standardization to prototyping, the early trials, and then addressing the commercialization issues from R&D perspective. So I like to think that over the past 8 years or so that we have solved the fundamental challenges of millimeter wave. So while some challenges do exist, I'll venture to say that it's not these challenges. So these fundamental issues have been solved. If we look at where we were 8 years ago, 9 years ago, we even, internally we were concerned about coverage, that it'd be too costly to densify. And that we've shown that we can actually co-site with existing sites and we can get enough coverage and enable a mobile network. We also thought that it would only work for line of sight. We've shown that non-line of sight is also feasible. We can get reflections from buildings and we can get it as long as there's enough link budget in the network, in the design. We also thought it would only be feasible for fixed networks, but clearly my phone itself has millimeter wave, and we have millimeter wave phones and networks particularly in the US, and it's certainly for mobility as well. And then 8 years ago, it was an immature RFIC technology. But we're also shown that we're already on the 5th generation of mobile RFICs, and with improvements every single generation. So we've certainly overcome that challenge as well. So if you look at where we are right now, this is a 3GPP perspective, just to put things in orientation. We started back in 2018 with the release of 5G. Every release has had significant millimeter wave enhancements and new designs, new topology nodes, new features come up. And currently we're wrapping up release 18, which was the first release of 5G Advanced. And we have 2 more releases in 5G Advanced before we move on to 6G. I won't cover 6G today, but 6G will certainly have millimeter wave as a core component, and that's something I firmly believe. And then deployments will begin in much more earnest worldwide in 5G Advanced. So for each of these releases, like I said, millimeter wave has played a major part. My team has certainly been very busy contributing to all these aspects. We've covered, we've had just better coverage for millimeter wave, better coverage and mobility. So things like L1, L2 mobility, better mobility across different network nodes in a network. improvements in beam management, and that's continuing even into release 18, where we have AI/ML beam management come in, and we've seen the benefits of that. Device size and power, we're already in the 5th generation. The power is always improving. The size and the antenna modules are always improving. And then robustness. So robustness not only in a network deployment perspective, which itself is improving, but also from a phone design perspective and antenna module perspective has improved quite a bit in the last 8 years. And then topology enhancements, that different nodes, smart repeaters or network controlled repeaters, integrated access backhaul, those things have come in standardization, and there are some products already in the ecosystem. So I won't cover all these, but this is just to make the point that there's been a lot of activity. So not all of these are millimeter wave, but certainly many of these are millimeter wave. So there are improvements in mobility. You can see all kinds of new use cases like centimeter level positioning, industrial IoT. There's a full duplex that has a big millimeter wave component as well. Integrated access backhaul, smart repeaters, mobile IAB. There are a lot of components that's developing a mature ecosystem for millimeter wave. And I expect that to continue in the next few releases as well. So something similar to this was shown, I think, by Nakamura-san. This is a little bit updated version. So Japan is, we see Japan as one of the pillars of millimeter wave. So first pillar being the US, where there's the most deployments in millimeter wave, particularly in Verizon, but also with AT&T and T-Mobile. Japan, all the operators have deployed significant millimeter wave sites. And then the third pillar is shaping up to be Australia, where there's a lot of interest in operators and there are some deployments already. And then the rest of the world, there are either allocations right now, or there are fixed wireless access deployments, or early mobile deployments, but there's significant activity and hope that there's going to be further deployments, and in particular in India and China. There's good activity in those countries. If you look at the ecosystem, and these are really Qualcomm-based chipset ecosystem, just Qualcomm-based, we have over 170 devices. So this includes 5G smartphones to PCs, CPEs, but then I think Nakamura-san also showed that there is a big ecosystem in repeaters and CPs from other companies and different base stations that this doesn't actually cover. So the ecosystem is fairly large already, ready for deployment. And so the ecosystem, if you pull it together, even today, we can address these initial use cases of fixed wireless access, indoor, outdoor venues such as this, transportation hubs, so airports, train stations, and then indoor enterprises and industrial IoT. Places where we have high capacity need, where we can actually target a deployment and perhaps overlay even with a sub-6 network. So we've actually done some measurements, and we've seen that C-band, the lower frequencies, does a great job. 5G is deployed everywhere around the world, in those bands. But we've already noted in the other presentations that the capacity is being used. So there's already an increase of 30%, I think, in Japan in the past year. So as the networks get congested, then we see that there's a benefit to deploying millimeter wave, because millimeter wave, in uncongested, of course, it's very high peak throughputs, but even in congested, where you can actually multiplex a lot of users, the data rate that we see is actually comparable to the peak of a C-band. So there's a lot of capacity to use. So the idea is not blanket deployment. I think early 5G deployments, even some early licenses said, let's just blanket deploy millimeter wave everywhere. But I don't think that's the right approach. I think the right approach is to start with the products available in the ecosystem now, target stadiums, train stations, conference halls like this, overlay with sub-6 networks, and we've shown that it's more cost-effective actually to address your capacity needs with millimeter wave deployments than more sub-6 deployments. It actually makes the performance better in sub-6, and then enables more capacity in in millimeter wave. So this is an extensive study that's available publicly. I'll touch a little bit on AI/ML because I know it's something that people have discussed in 6G, but I want to point out that it's actually something that's we're already leveraging today, and in particular in millimeter wave, both in standardization and in our products as well. In our products and also our planning for 5G millimeter wave networks. First, in release 18, we just wrapped up, so the middle column here, in particular, the beam management for millimeter wave, is something we've tested on our own networks in Qualcomm for a number of years, and we see huge benefits on both the UE side and GNOP side for both power consumption as well as performance. So this is, I think, a very clear use case that many companies have seen, and it's it's going to continue in release 19 as well. So I expect this in 5G Advanced to be in products. And already, in our own network, we're actually using our Qualcomm devices because our Qualcomm devices already have a neural network in there, and it already has some AI/ML-based beam management. That's just the overlay, so it doesn't require any standards. So already, if you use a millimeter wave Qualcomm phone, a lot of the initial access, quicker initial access and beam management is already AI/ML driven. So this is a strong use case for it. Another area that we do from R&D, my team does, is this intelligent 5G millimeter wave network planning. So where we actually look, so in this particular case, it's Manchester, where we have a sub-6 network. We use a digital twin, we create a digital twin of the environment. We look at how to address capacity needs around places like Manchester United Stadium and the rugby stadium, and figure out whether it's better to use sub-6 or millimeter wave to address that capacity need. And we look at different options, we look at different cost structures of running fiber, a site location, and then we utilize repeaters and the millimeter wave base stations. And we clearly see that overlaying millimeter wave sites and repeaters on top of a sub-6 network benefits both the sub-6 users and sub-6 network, as well as offloads capacity onto millimeter wave. So it's certainly the right approach to targeted create hotspots of millimeter wave to address capacity needs even today. So just to conclude here, I just want to make the point that we have a mature ecosystem already. And I've been looking at this for 8 to 9 years, but the deployments, especially in the US, have been around for the last 4 years. Many companies around the world are working on products. So we're commercial in pretty much all parts of the world. There's a mature device infrastructure ecosystem. We're already being capacity restricted. We're running out of capacity. Networks are getting congested. I've seen statistics from around the world. So there is a need for more capacity where millimeter wave need is there. And we've shown that millimeter wave is actually the cheapest solution. So the cheapest way, the best way to address that capacity need on the networks. So I think this is the time where really millimeter deployments will take off and the ecosystem is ready, and as we go into 5G and 6G. Thank you.
Thank you very much, Mr. Osuke Koimen. Next from Ericsson, we have Mr. Christopher Price. He's going to talk about millimeter wave solutions and business opportunities. Mr. Christopher Price, please.
My name's Christopher Price. I work with Ericsson. It's my pleasure to be here today to talk about millimeter wave, the opportunities that come with millimeter wave, and the potential that it has for the 5G ecosystem. I am an Australian by birth, a naturalized Swedish citizen, and have lived in California, Australia, Spain. I've traveled around a bit and worked on communication technologies during those travels. For today, I'm going to adopt Australia as my home because of their progress on millimeter wave as I talk about the technology. I'd like to start by saying 5G is here. but it's still coming. When I think of 5G and when we talk about monetization and when we talk about being able to leverage the 5G network, we're talking about 5G standalone. And when we talk about 5G coverage, I like to think about what is the 5G standalone coverage that I have and how am I then able to leverage that to deliver services. It's important also when we bring millimeter wave in that we have a 5G standalone network as a strong foundation upon which to build. Earlier today, we heard about quality of experience, which is extremely important. I will reflect that since being here in Japan, I've noticed something on my phone that I haven't seen in other countries for quite a while, and that is the 4G logo popping up on my phone. I don't seem to always get 5G here in Japan. Sometimes I get 4G here in Japan on my 5G phone, which isn't that common in a country that has such a great penetration. So the quality of experience, there is always room for improvement. Making sure that we have a good, solid foundation on 5G as a standalone network in the mid-band is very important to enable millimeter wave moving forwards. So I want to talk about millimeter wave. And to begin with, I'll put up a slide which is very similar to those that others have shown, and that is what are the deployments and how are we seeing millimeter wave as of today. And along the bottom, we can see the public network allocations of millimeter wave frequencies. So as we can see in Japan, we have around about 400 megahertz allocated through most operators here to use. In Australia, we have Telstra who have a gigabit, Optus has 800 meg, and NBN has a gigabit in various bands deployed for public network. On the vertical, there is a local spectrum. So here we can see my other home country, Sweden, has allocations of millimeter wave for private networks, for local location-driven millimeter wave deployments. Both of these are quite useful and prevalent, and we see innovation occurring across both of these domains. 26 to 28 gigahertz then, these are the global pioneering bands. These are the bands where there will be ecosystem developing, where there's a lot of collaborative work, where we expect to see more devices, more capability, and more penetration. Local spectrum is quite common, and we see local spectrum is extremely important to help develop ecosystems. The millimeter wave ecosystem is more mature now than it has ever been, and it will continue to mature. And those local ecosystems will help drive new capabilities, new services, new devices that will then emerge into the public network as the public networks improve and as the user experience for millimeter wave improves in those public networks. And down to the bottom right, we can see the continued increase in millimeter wave spectrum awards. This isn't going away. This isn't on a decline. It's clearly growing, and each year we see more and more countries allocating spectrum and trying to get ahead on millimeter wave. So I wanted to focus a little bit on use cases rather than the technology itself. This is a bit of a busy slide, but it talks about the fixed wireless access use case that we have for millimeter wave. It's an early, easy to sell use case that leverages the frequencies that operators can take advantage of. It's not too difficult to deploy. It's relatively easy to build into your existing offerings. The millimeter wave CPE shipments are more than doubling each year. From 2019 to 2021 to 2022 and 2023 are here. As you can see, 800K shipments of millimeter wave CPE devices. In other words, there is a prevalence of devices out there that can be used in this service. And interesting where we see it deployed, Verizon, of course, an early leader. There's some great examples of how Verizon have essentially used millimeter wave to provide broadband services to towns which haven't really had very good services before. If you've seen in the news, NBN recently announced a 1 gigabit connectivity capability with millimeter wave at 10 kilometers. So it's not 100 meters, it's not 800 meters. We can go up to 10 kilometers and get one gigabit throughput. What we typically think is around about 7 kilometers is that boundary where you'll still get very good throughput. But when addressing regional and remote areas, that's fantastic. If I can get multiple gigabits of connectivity in a 7 kilometer range, then I can serve hundreds of houses with a very good broadband connectivity, quite cheap. Good. The other use case I want to discuss, and it's been hinted at or maybe discussed in detail, but the indoor and enterprise use cases. What millimeter wave provides, and what we've seen in measurements, is great throughput and specifically great uplink. Devices can say a lot more to the network than they've previously been able to. So high-def video on a device shipping to a network to be consumed and used for a particular purpose. These are now capable to be done in multiple instances on a factory floor using millimeter wave technologies. In addition, the latency characteristics we see are significantly better with millimeter wave. I can start to do very detailed, intricate control activities remotely using millimeter wave as a fiber replacement. And of course, the flexibility, the ability to move things around the floor, the fact that I don't have to run cable, makes millimeter wave an exceptional tool for factory modernization and use case development for wireless capabilities in enterprise. The other use case then, as we move forwards and as we start to see these ecosystems develop and expand into broader use cases, is the macro use case. How does millimeter wave help me in my macro network? How does it help solve connectivity issues for the average consumer? And I took Australia as an example here. So Sydney and Melbourne, here are some spot maps derived from the ACMA register, so public information, of how millimeter wave is deployed in Sydney and Melbourne. You can see in the Melbourne, down to the right, there is a stadium there and it has millimeter wave circled around it. This is quite common. The millimeter wave in those stadiums can serve hundreds of thousands of people, well, 100,000 people, let's say, at any given time, providing an excellent connectivity experience, not just for watching a sports game, but for concerts, for interactive experiences that are going to be developed. How you can use that connectivity changes the type of experience you can provide in a venue like that. So it's not just today's problems we need to solve, it's creating opportunities to develop new capabilities and to bring new experiences to the market through connectivity. We can see the numbers in Australia, they're not huge. This is obviously a growing trend. You can see Telstra continue to invest, and they're investing carefully. If you walk down the streets in these cities, you'll notice that on a long street there'll be a millimeter wave antenna just pointing down that street from one of the poles nearby, and they're very carefully sort of cross-sectioned and figured out. Okay, here's where the people are going to be and where the people are going to hand over, and here's how we need to structure our network in order to address this space. We saw earlier that the number of devices, user handset devices in Australia, is not that great for millimeter wave. So this is really a preemptive deployment to make sure that as those devices are enabled, the capability is there to take advantage of that and to deliver excellent experiences for consumers in the network. I wanted to finish with a little bit of a discussion on aggregation. I saw on a slide a little bit earlier, there was the NRDC slide. So we expect to see NR radio carrier aggregation becoming prevalent in networks moving forwards. It's extremely important that we're able to do that. I talk about 5G standalone as the 5G that I measure, because if I want to do dual carrier aggregation of NR, I need a standalone network in order to support that. And what that allows me to do is it allows me to take the mid-band capabilities that I have and aggregate into the millimeter wave. In other words, I can have service continuity as I move in and out of a millimeter wave environment. So if I turn a corner and I drop off or I hit a blind spot, I can still use my carrier aggregation solution to provide a more seamless user experience than I've been able to previously. So we did some simulations in Ericsson. So we took a system, let's say 150 meters site to site, 21-meter high antennas, so rooftop antennas, 3.5 and 28 gigahertz on every antenna, 3.5, 2.8, and 70% of traffic we decided would be modeled as indoor traffic. So we expect 70% of network usage to be indoors. So it's not just modeling people walking down the street, for instance. What we saw, traffic distribution per band, when you're outside, 81% of all traffic was carried on the millimeter wave bands. When I move indoors, I lose a good portion of that. I get down to 30% of my traffic carried by millimeter wave. This is important to recognize. Even though I've moved indoors and even though I'm using millimeter wave, according to our models, we still expect to see almost a third of the traffic carried on the millimeter wave bands. So we expect to see millimeter wave improving the indoor user experience that we would expect. And overall, it's almost 50-50. We see 44% carried on the millimeter wave bands and 56% carried on the mid bands. And this is based on a 70% indoor utilization. What's very interesting then is if you look down at the outdoor median speed, if I'm using 3.5 gig only, so if I'm just using standalone 5G, I get just a bit under a gig of throughput. If I add millimeter wave, that pops up to above 4 gigabits of throughput that I can achieve. If I'm indoors, mid-band only, I get 0.6 gig. But if I'm indoors and I add the millimeter wave, that doubles to 1.2 gigabits. So we see as we're able to introduce millimeter wave into the network, we don't just improve the outdoor experience, we improve the indoor experience. The offsetting of the mid-band by having outdoor users more on the millimeter wave bands only improves the experience of the indoor users on those mid-band frequencies. So I'm going to sign off with here, and thank you very much.
Thank you very much, Mr. Price. We'd like to move on to the next presentation. The speaker is Mr. Niels Koenig, 5G ACIA Fraunhofer. He will speak about millimeter wave spectrum for industrial 5G potentials and challenges. Mr. Koenig, please take the floor.
Okay, so yeah, my name is Niels Koenig. I'm working for the Fraunhofer Institute for Production Technology and IPT in Aachen, Germany. And at the same time, I'm serving as the vice chair for the working life at the 5G ACIA. We'll talk about millimeter wave for industrial 5G potential and challenge. And when I mean industrial 5G, then I'm focusing mainly on non-public networks. So we have learned a little bit about the situation for public networks already. And now I'm focusing mainly on non-public networks. So what is the relevance of 5G millimeter wave spectrum from an industrial end user's perspective? So first of all, 5G millimeter wave spectrum has certain advantages compared to sub-6 spectrum. So first of all, there is access to licensed spectrum with much higher bandwidth than in sub-6. So for sub-6, typically it's up to 100 megahertz for private spectrum. But for millimeter wave, it's much higher. So like up to 800 megahertz, which we have, for instance, in Germany. So with that, of course, there is the potential for higher data rates or even lower latencies. And furthermore, the interference management becomes much easier, especially if you deal with adjacent spectrum, which is the case for sub-6, so where the private spectrum may be adjacent to the MNO spectrum, and also with adjacent non-public networks. So, of course, with millimeter wave, the attenuation is higher, so there's less risk for interference. So this makes, on the one hand, the radio planning easier, and there's not so much the need to take care about your neighbors. And then furthermore, you have a higher flexibility because of that on adjusting to non-standard TDD patterns. So TDD patterns in sub-6 are typically coupled to the patterns that you have in the public networks, like mostly downlink heavy. And with millimeter wave, you potentially are much more flexible, like you can set downlink heavy patterns or uplink heavy patterns, depending on the use case. Then furthermore, when looking at the global situation, it's important to understand that today, so to our knowledge, 13 countries have already decided to grant millimeter wave for non-public networks, and 6 furthermore in discussion. And compared to the sub-6, the situation is actually quite good because for private sub-6 spectrum, 15 countries right now have decided to grant private spectrum. As you can see in the map, most of the industrialized countries have the possibility to apply for private millimeter wave spectrum. But of course, there are certain drawbacks for millimeter wave spectrum in industry. On the one hand, we know about the propagation physics, and there's higher attenuation, or let's say less transmission range than for sub-6 spectrum. From the industrial perspective, it's also, we can see there's a lack of availability of industrial grade 5G devices compared to sub-6. And also there's not so much of experience whether millimeter wave in industrial context is robust or not, or is robust enough. Okay, so let's talk about certain use cases. So which use cases actually have a high demand for bandwidth? So we know already a lot of use cases from 5G and related to sub-6, but which of them are uniquely using millimeter wave performance? So on the one hand, we have to look at uplink heavy use cases. So uplink is much more in the focus from industry than downlink. And for uplink heavy use cases, you can imagine machine vision. So machine vision is typically used for quality inspection. And especially if you demand high resolution and high frame rate, then you have a high user data rate. And also, you can imagine pick and place operations, perhaps with a mobile robot, and everything is camera guided in these applications. And cameras today are widely used with GIG-E interface, so that's an Ethernet interface. So that has 1 gigabit or 5 gigabit or 10 gigabit per second interface. These are pretty common in industry today. Then furthermore, there's also a trend towards 3D imaging, for instance, with stereo vision that uses 2 cameras at the same time, or time of flight. And then furthermore, what is also important, you need to have a triggering and synchronization of the machine vision with, for instance, conveyor belts or robots. And therefore, low latency and low jitter is often needed as well. And additional applications come from inspection with mobile systems where you can imagine to capture a video that can be done with a drone or an AMR. For instance, you may know the Spot, the robot from Boston Dynamics that could be used potentially for inspection, especially in huge facilities in the process industry. Which use cases are looking for downlink? So you have to really search for downlink heavy use cases actually. And there are just a few. And the most prominent one is from the automotive production. It's about downloading software and firmware of the controller systems and the multimedia systems in a vehicle that may not be limited to these typical cars, but also to trucks as well. This kind of software and firmware, they need to be downloaded and flashed in the continuous flow production. And actually, you want to do this for multiple cars at the same time because the volume of this kind of software and firmware is increasing constantly. And now we're talking about multiple gigabyte or 2-digit gigabyte data size per car. So that means that you are looking for high bandwidth on the downlink. I want to add that at the same time, having larger spectrum and from the regulation, there's also possible for 5G millimeter wave to increase the sub-carrier spacing and thus decrease the slot size. So that means actually you can furthermore decrease the latency potentially, and in theory, we have to look at the situation, what is happening with the networks and the devices. So both of them have to support that the latency goes down. So we have started to test millimeter wave industrial applications, and 5G ACIA has the testbed initiatives. And we have started a 5G ACIA endorsed testbed called 5G millimeter wave for industrial applications with high bandwidth demands. So we have 6 testbed members, and we have started this year. And this will take like 2 years. And we have 6 partners. So Fraunhofer IPT is developing use cases and carrying out measurements. And Ericsson is our infrastructure partner, providing the installations of the millimeter wave equipment and carrying out also measurements. And then we have Qualcomm, because it's important to have the chipset and device side also on board, because as I've already indicated, the device situation is for millimeter wave is not as good as for sub-6. And then we have Basler and Volkswagen as partners for use cases on machine vision and also on the automotive use case, and also Rohde and Schwarz, because we want to carry out measurements under real factory conditions and see how good is the penetration of millimeter wave on a shop floor. So these activities are also embedded into a European research project called TargetX, which is being funded by the European Union in the 6G SNS framework, which we have already seen on the slides today. So the testbed is located at the 5G Industry Campus Europe. We operate a 5G NSA and NSA network. So we have radio and core networks supporting LTE and NR. And we operate NR in 2 frequency ranges. So in the band N258, 26.7 to 27.5 gigahertz in the TDD spectrum. And we have N78, 100 megahertz in frequency range 1. And as anchor bands, we have 2 different anchor bands, band 40 and band 7. And the facility which we cover with 5G is has a size of 2,700 square meters, and we have approximately 50 different machine tools on the shop floor. So, and this is how it's looking like. So you have this conventional machine tools piled up here or stacked up in the shop floor, and the aisle that you can see is 19 millimeters long. And you can see now here from the other side. So you see on the top of the aisle of the shop floor the antennas, especially only for 5G millimeter wave. And then we have the small antenna, which is the anchor band. So that's for band 7, which we had to add. And the 5G NR frequency run network is based on the radio dot system from Ericsson, and these are small dots. You don't find them on the photograph because they are too small. And applications that we are looking at is really looking into machines and coverage in machines, like for instance, machine vision in machines, or also sensor applications like vibration sensing. And so we have first results that you can see here. So this is the coverage of millimeter wave on the shop floor. You see the shop floor here, and the location of the antenna is approximately here. And when we have measured with this wagon and the MTP from Qualcomm, the coverage quality. And then, of course, in front of the antenna, because the antenna is hanging 6 meters height, that means that the divergence of the beam takes some time to unfold, let's say. And then if we progress, then the coverage decreases. So we have here a length of approximately 60 meters. And then if we go to the other aisle, then the beams are blocked and there's no coverage at all. That's not a surprise. But of course, we are working on that, how to improve it. and without hanging too many antennas. So the peak rates with regards to the download and upload is for the download. Sorry, I mixed up the numbers here. So download is up to 4.2 gigabit per second, and the uplink is 1.2 gigabit per second. So it's looking quite good already and sufficient for most of the use cases I've indicated. And of course, the signal decline is rather high, and we will see in the outlook what can be done. Okay, so some other use case. So it's let's say a fun application. So we have designed a 5G-enabled table football. You see the table football on the left side. And there you can see that we have a camera, a gigabit Ethernet camera, which takes images at 120 full frames per second. And then we have the table football, and the camera is attached to a Quectel evaluation kit with an M.2 module for millimeter wave. And all of the data are transmitted via the millimeter wave network. And here, even we do not have proper line of sight connectivity, but still it works. And the images are processed on our on-premise edge cloud. So there's a NVIDIA GPU accelerator attached to the edge cloud. And you see we have an AI-enabled ball detection. And as a next step, we will take motors to control the goalkeeper in order to prevent that someone can shoot a goal, and also to demonstrate the performance and the speed of 5G. That's just a fun application, but nevertheless, it shows the performance of machine vision. So we've seen a little bit of the challenges, and I would motivate that we have a look at combining frequency range and frequency range 1 and 2 in order to take the best of two worlds. So that means, for instance, use NR as anchor band. So take, for instance, the 100 megahertz plus the 800 megahertz to increase furthermore the bandwidth. And then, of course, also look at the coexistence of frequency range 1 and 2 in order to orchestrate the use cases. So some use cases may be looking for low latency, and others may look for high bandwidth. So that's where we need some kind of intelligence to orchestrate use cases and allocate them to frequency range 1 and 2. For instance, combine machine vision with field bus communication, for example, for CC-Link IE, TSN, or Profisay. Then furthermore, we need to improve the device ecosystem, because right now the market available devices for millimeter wave, they do not support 5G SA. They only support 5G NSA. But this will come, of course. And furthermore, what is making it a little bit complicated, that the band communication combinations for FR2 devices differ from FR1 devices. So that's something which we had to learn. In order to enhance the coverage for frequency range 2, we think about reconfigurable intelligent surfaces, RIS, as intelligent reflectors, because we see that for frequency range 2, the attenuation is significantly higher than for FR1. And we basically rely closely to line of sight dependency. And RIS can be used to cover blocked areas. For example, you could place RIS in front of every machine tool in order to have a penetration in every machine tool. And in combination with active antennas, even static RIS might be used. Okay, I hope I could show you some examples and also highlight the challenges ahead. And I thank you very much for your attention.
Mr. Niels Kinnich, thank you so much. Next, from KDDI, we have General Manager, Mr. Tatebayashi Shunpei, in charge of Web3 promotion. His talk is titled The Changing World Through 5G, the Current Landscape of Metaverse and Web3 Service. Alpha U. Mr. Tatebayashi, please. Tatebayashi from KDDI here. I appreciate this kind of opportunity. From myself, I'd like to talk about the changing world through 5G. So I'm going to talk about the Alpha U, which is the Metaverse and Web3 service. I'll talk about the current landscape of Alpha U. Skip over the company introduction. Talking about myself, I'm in charge of new business promotion. Metaverse, Web3 business is what I oversee. Also, I work with startups to create new businesses. That's another mission of mine. So fund for startups is another thing that I oversee. So I am originally a network engineer. So I think I am able to understand what the other engineers are saying. But in my session, I'm going to talk about the use case being changed by 5G. That's going to be my focus. Company introduction, KDDI. We're focusing on sustainability management and satellite growth strategy. So 5G communication is going to be the core, and we're going to develop businesses around that as satellite. That is our business strategy. So looking back, history of KDDI, well, international telephone and fixed telephony was where we started. Then with the evolution of technology and the change in the market environment, the core business has shifted or pivoted. That's been the history of our company. So where it says telephone, from there we moved to internet. So a fixed circuit internet gradually shifting there. And then later the mobile ratio increased. And we, of course, did not do everything on our own. We collaborated with many companies, including startups. We asked them to join the group, harnessing their technology and the know-how to expand the size of our operations. Now, in the era of 5G, what should we make and what kind of company should we transform into is what we have been thinking about. And so open innovation is going to be the axis around which we will promote business. So in order to promote businesses with startups, we have two major schemes. One is the KDDI Infinity Labo. So we support the startups. So KDDI supports startups not on its own, but large companies coming together. 84 large companies joining. So together we support the startups. That is the KDDI Labo. And then from the startup perspective, well, they do a pitch, want to find a collaboration partner, and then they're able to make connections to 84 companies, so it's very efficient. Then we have another fund to invest in startups. We have invested in 134 startups to do business collaboration with startups. Now, millimeter wave is the theme for today. So I'd like to talk about some cases, examples that the KDDI has been involved in millimeter wave. In 2020, we launched the 5G service. At that time, we started with the millimeter wave. The characteristics of millimeter wave has been harnessed in the environment. And we also wanted to impress the users so that they have the experience and can be convinced that 5G is great. So that's the kind of use case we have been pursuing. So sports is one pillar. And then in symbolic locations in the city where there's a huge high density of people, and then also entertainment halls, we create a millimeter wave environment so that users or consumers can have new experiences. So we've started service, including some experimental ones. So one of the use cases, there's the Yoshimoto Infinity Hall. We introduced 5G to their hall, and so the two comedians are distant to each other, but they can do comedy together, or you use a smart glass in a museum, and you can do translation of languages or the detailed information can be displayed in the glass. So that's something that we offered. And also in the material you saw that in a very limited area, I mean, it's an open space, but in a limited space, you can introduce millimeter wave, have large capacity communications where its characteristics can be utilized well. So we deploy in stadiums. So if you have a smart glass, you can see the offside line using the smart glasses. That's so right-hand side video doesn't play, but you watch the game with the smart glass. Then you can have the offside line, and you can also get the information about the players. So we provide that kind of service to the spectators at the stadium. Now, looking at the current domestic situation, so using it in stadiums or in the cities to provide the AR experience, because of COVID, it was difficult to do those implementations for a year or two. And so we shifted our direction to Metaverse, and we have been promoting Metaverse services. And then as a development of that, Metaverse Web3 service Alpha U was launched this past March, and we're promoting this now. So we're a telecom carrier. So how do we position this is what I would like to clarify here. So there's the network evolution, and the way consumers use terminals is gradually changing. And then the service is evolving based on that. That is how we perceive this. So at the time of 3G communication, email, and visiting home pages, websites, that was the mainstay of usage. But with the development of the 4G environment, ordinary consumers, they can upload contents. It's a stress-free environment to upload contents from mobile devices. That became popularized, and then as a result SNS became quite popular, and then YouTube, where you can submit videos, that has also become very popular. Now if you have the 5G environment, what kind of world will we see? Two things we have in mind. One is compared to the 4G era, there'll be a larger number of users who will submit content, so the UGC will expand, and Web3 will be the technology to support that. That's how we see it. Then what was text is going to become images. What was images will become video. So what is video going to turn into? What's next? So we think that all the objects are going to become 3D. That is a possibility. So toward the 5G era, Metaverse and Web3 is what we are promoting. So 5 services, and it's difficult to see. Please watch the video. I think it's easier to understand.
Hi.
Okay, sorry, couldn't play the video, so skip that. So talking about the Metaverse, on this smartphone, you can experience the Metaverse. So from 2020, we have collaborated with the Shibuya Ward, Shibuya City, to operate the virtual Shibuya. And so this is an extension of that, a more developed version of that. I'm a middle-aged man myself. So Gen Z people, they get to know people on the internet, and they enjoy chatting with them. That has become commonplace for that generation. So Metaverse, it's something that you use not just for particular events, but it's like an SNS. So you use it like if you're just standing in front of the convenience store and chatting. So we provide voice communication, and then you create a room where you can show your experiences. So that's the services that we operate. For Web3, domestically, Web3 market is still in its early stages. So maybe some people feel that it's difficult to understand, or it's a little bit frightening. So there's a little bit of resistance amongst the general consumer. So carrier like ourselves, so we can provide that the sense of security. So safe and secure Web3 wallet or market is what we provide. And we want to collaborate with startups in this regard. And in Web3, culture. We want to support the players who originate from Japan and go to the world. So September, we have complied with a wallet chain, and we implement the Oasis and try to create an environment where we can support companies going from Japan to the international market. So metaverse. So I think many of you have experienced this, tried it, and I think the focus is still on games. It's still limited to sort of a gaming environment. And so when you want to buy clothes, would you want to look at the clothes with a polygon that's designed with polygons and select? That's a little difficult. And experiencing live performances in a metaverse, I think technologically there's still something lacking there. So live and the commerce, I think that should be separate from metaverse. We provide it separately where they can experience those things. But though those who visited physically and those who visited virtually, I think the impression they get is different. So what you can go experience in a physical world, we want to create an environment where people can experience that on the internet. That will be a richer experience, and there will be less stress for the consumer. So when 5G started, we wanted to create a new experience in the physical world, in the real world, and then because of COVID, we're shifting a bit on the metaverse side, but experience in the physical world and the virtual side experience, that should be set up, and then that can lead to interesting experiences for the consumer. So data or the events that happened in the real world, how to take it, how to upload it to the internet in real time, we think that will be important. And I talked about the sports and entertainment, but including factory, where there is data, you want to upload as quickly as possible, and then you analyze that on the internet. So from real to virtual. And then you do the analysis or do some processing on the virtual side, and then return it back to the real world. How to do that in real time, we think is very important. So gradually, the area coverage of 5G is expanding, technology is developing. So real and virtual, we should create a use case where there is a good cycle between that. And I think that will help to develop the environment further. I'm sorry I couldn't show the video, but with that, I'd like to close my talk. Thank you so much.
Thank you very much, Mr. Tadebayashi. With this, we'd like to close session 1. From here, we'd like to take a break for 10 minutes. We'd like to start session 2 right after the break when we are ready. We'd like to ask for your cooperation. Thank you very much. Thank you for waiting. We'd now like to start session 2. Here in session 2, we will look into millimeter, the status quo of the millimeter and the future perspective. This session will be moderated by Mr. Sekiguchi Waichi, President, Research Institute, former editorial writer and columnist for Nikkei. Mr. Sekiguchi, please take the floor. Thank you very much for your introduction. My name is Sekiguchi. I'm president of Research Institute, which looks into IT research. This is the last session. I'm sure you are all tired, but we'd like you to be with us. We have been discussing 5G, current status, and the perspectives from different points of view. And here in this final session, we have been focusing on millimeter wave. This is the last session. So we'd like to here look into the future perspective of the 5G as a whole on top of millimeter wave. And I'm quite sure that we have a very good panel members here. Most of them in the audience are Japanese. We have the speakers from outside of the country, but we'd like to conduct this session in Japanese. In the morning session, Professor Morikawa of the Tokyo University made a contribution to the Nikkei last year in December, and he said that according to Gardner, the United States, which is related to the hype curve, and then hype curve is about people getting so excited, and then after that, people just lose the interest in that. So this is this is to solidify the situation. So when the 5G came into force, it was 4 years ago, and we had a face-to-face meeting, and I was also here at the discussion. The Tokyo 2020 was 1 year down the road, and we were about to see something quite new, and we were very much excited. But very unfortunately, with COVID-19, things didn't go well. And Tokyo 2020 was considered to be a great tool for momentum for 5G, but we had to go into the stagnation. And the last year, we had that kind of a very low status. But this year, we have seen many good things, and also surrounding environment is such that we are now able to utilize the AI and the quantum computing and the metaverse. Many new technologies are coming into force, and then all in all, we are able to have a momentum which will drive the growth of 5G. It is important to get a hold of this, and it is important to make the best use of what is available. I think this is a mission that you have to live up to. This is for all of you who are staying here. So with this in mind, we'd like to go into the panel discussion. And here, I'd like to introduce the panel members. Well, actually, they are all from the previous session, so I decided not to do this. So first, we'd like you to think about, see how you are looking at 5G at this moment, especially about millimeter wave. As was mentioned, in terms of infrastructure, Japan has been ahead of others. And however, as was mentioned by the general manager of communication, it has not been utilized. So, but we have in the United States, it's gaining momentum, and also the third pillar of Australia would also rise. Then let's go back and look at the situation in Japan. What is taking place in Japan in regard to millimeter wave? So I'd like to ask this question to Dr. Lee of South Korea.
Thank you for giving me a chance to think about the millimeter wave. Actually, personally, I was one of the promoters of millimeter wave in Korea. So I regret that the current status to getting back the license of a mobile operator. But it's a good sign that the government is considering additional new operator for using millimeter wave. But the big change is that previously, the licensing condition is to deploy the millimeter wave network nationwide. So it costs big investment and long time. But the new condition is to allow them deploy the network locally or regionally. So I think with that condition, some business opportunity for new mobile operators. And it is clear that the benefit of millimeter wave because of high bandwidth and low latency. So I think in midterm, I think we have some chance. And in addition, as I said in my session, that we are preparing for beyond 5G, 6G. And on that generation, I think millimeter wave or even sub-Tera is also one of the candidates. So in the long term, we have some you can see some good signal. That's my view. Thank you.
Thank you very much. So this is the situation in Korea. You terminated this for a while and then resumed this activity. And then, Komine-san, would you like to answer? Mr. Koiman, can you hear me?
Sorry, there was a delay in the translation. So US represents the first pillar of millimeter wave deployments, and that was mostly because the allocations happened first, and actually was the only 5G allocation initially. So then Verizon in particular deployed 5G millimeter wave. Although I do think that the approach of deploying just millimeter wave was probably the wrong one. So Verizon certainly has the advantage that U.S. Operators have an advantage that they've deployed their experience in it. But I think the approach that Korea is taking now is a better approach, where you target it, and it's not meant to be a blanket deployment. It's more of a overlay for capacity to sub-6. So I think if you look in the United States, even though it's deployed everywhere, it's sparse in some areas. But the places where it's successful is actually where they've gone that approach, in some of the downtown areas and in a lot of the stadiums and transportation hubs. And that's where you really see the benefit. I mean, my phone itself has a millimeter wave, and I do get to use it when I go to these environments, and in particular in these stadiums where all three operators in a place like Sophie Stadium have deployed, and the benefit is real. There's certainly they address the capacity need. So even though there was an early start in millimeter wave, and now there's significant penetration, it's really now when these hotspot locations are coming up, and we're really seeing the power of millimeter wave to address capacity needs.
Mr. Price?
I see the advantage of millimeter wave in bringing additional throughput to use cases where we have a need and where there's a business value. So if I think of the value of millimeter wave, I need to build on top of what it is that I get from 5G. Where am I bringing new services and new capabilities into 5G that are more demanding, that have more uplink requirements, that have more stringent requirements on downlink, for instance? Automotive cars industry, we have self-driving car or assisted driving types of use cases where there are very stringent requirements on what the network has to provide, and it has to provide that over a broad area. In dense areas where, for instance, there might be 10 or 12 cars, in a standalone environment with just mid-band, I will not have the capability to deploy 12 different slices to support the specific capabilities I require in that instance. So millimeter wave can provide, in those dense areas, the needed bandwidth to bring those new capabilities and those new monetization opportunities to reality. The monetization will only go as far as there is something to sell, and millimeter wave provides that extra something to sell as those use cases become more apparent.
Then we'd like to ask the situation in Europe and in the Germany. Mr. Kenny, would you like to make a comment?
I mean, we have to make a difference between the PLMN coverage, so the public networks, and the non-public networks. So I was talking about non-public networks in my presentation. So the situation for the public networks in Germany, and I think in whole Europe, was also shown by one of the speakers. There's no millimeter wave deployment in the public space. So, and when it comes to the private networks, especially for industrial applications, I would say that millimeter wave has a lot of potential, but there's much more deployments in sub-6. That's due to the fact that sub-6 spectrum for private use was available much earlier than for millimeter wave. And the ecosystem is more developed for sub-6. But yet I would say that millimeter wave has the benefit on top of sub-6. So I think sub-6 plus millimeter wave is, let's say, for the advanced industrial 5G users who want to make more out of it. That's what I see. And adding millimeter wave on top of an existing sub-6 deployment is not such a big deal, because just takes a little bit more equipment, but the rest of the equipment may already be there. So the situation in Germany is when it comes to the private networks, there are statistics from the German regulator who grants the private licenses. So we have approximately 350 sub-6 licenses granted today and 18 for millimeter wave. So that shows a little bit the maturity of sub-6 and millimeter wave deployments.
Thank you. So Nakamura-san, I want to ask you, talking about, well, you have the report from the ad hoc committee for millimeter wave promotion committee. So I think that shows that we're still behind the international community. So how do you see this situation?
Okay.
Was I supposed to speak in Japanese? You can speak in Japanese because we have interpreters.
Japanese. Sorry for everyone.
So ad hoc committee, where we looked at the deployment situation, we did the analysis of the trend and compiled the report. So millimeter wave, it's been deployed to some extent, stations, stadiums, it's being operated there in those places, but still, as a public network, we haven't sufficiently deployed a millimeter wave, and in terms of the traffic, it's just a small fraction that's carried by millimeter wave. There are some area issues, and terminals that support millimeter wave not popularized in large numbers. That's another reason. And the NTT, as a person from NTT Docomo, if I may comment from that perspective. So millimeter wave we have been introducing to stadiums and stations from the early stages of 5G. But as I said, traffic ratio very limited. However, just last week, there's an event area at the Tokyo Sky Tree. It's called Sky Arena. There, we did some millimeter wave event. At that time, using the characteristics of millimeter wave, high quality XR was introduced, and high quality video streaming was provided. So high speed, high capacity communication was utilized for various applications, and those applications were provided to the general consumers, and many consumers enjoyed that. So in terms of use in the public networks, so combination with entertainment was proven to be very effective with that event. And also, going back to my position as the head of the ad hoc, as when news talked about non-private network or private network, so there's expectations, great expectations for that. And in the white paper, we wrote about it. So there's the affinity with the local 5G. It's a very high affinity there. So private network, local 5G, applying to that is where there is a lot of expectation. Having said that, though, many companies still focus on sub-6. They consider that to be the mainstay. So the order will probably be they use sub-6 to expand the use case for local 5G. Then on top of that, millimeter wave use case or application will be expanded. I think it will be in that order. That's all. Thank you. So Tatebayashi-san, I want to ask you, in your talk, you talked about starting from millimeter wave, but then COVID came, and then outdoor events became difficult. So you shifted the business model toward metaverse, is what you said. So as from the viewpoint of using 5G, how do you see the penetration in Japan and around the world? So as rather than telecom carrier, but commenting from the person who's developing business on top of that, at the stadiums and entertainment, using millimeter wave, augmenting experiencing, expanding experience. I think compared to the conventional infrastructure, there should be more points for monetization. For example, if you go to the premium seat, then you have the smart glass, and then you can learn about the players, and you can see the offside line, and there should be customers willing to pay more for that experience. So with telecom, just providing the telecom service to everyone, I think it's easier to monetize with the millimeter wave. So that's why we developed those use cases. But because of COVID, you can't have live events, concerts outside, no spectators in the sports events. It's not that the monetize became difficult, but the development of use case has stopped. And then the subsets expanded. So it should be serviced for everybody. So this work moved to that side. And then now with the end of COVID, we're seeing increase in inbound tourists and customers returning to the real world. And in festivals, they were all full, the musical events. And I think the real events are very well attended. So using millimeter wave and monetizing that, it's 2-3 years behind schedule, but it's going to emerge. And if monetizing is realized, then companies want to introduce this. Those who own the locations, who own the IPs, they will be more willing to introduce this. And then if that happens, millimeter wave, the applications will become clear, and we'll have an environment where it will be more conducive to promoting that. Thank you. So I think it all depends on how you do it, but what approach to take we can discuss later. But let's talk why we have not seen the dissemination. We have to do that diagnosis first. So Korea introduced 5G about a day earlier than the US. So it's I thought it was at the forefront of the global development. But for millimeter wave, you terminated the alliance. Why did you come to that situation? Can you explain that, please, Dr. Lee?
Yeah, I think that is a very important question. I think there is I think the big difference between USA and Korea in terms of millimeter wave service, that the consumers' characteristics. I think that in users in America maybe are familiar with the outdoor coverage condition of mobile service. For example, in inside the building or subway, or they are familiar with the outdoor coverage. But in Korea, the Korean consumers cannot accept the kind of outdoor coverage of mobile service. So that is why the Korean mobile operators hesitate to deploy the millimeter wave network in fast manner. Because if that is announced officially service, then the consumer may complain if their service is blocked in millimeter wave. For example, the Korean government is periodically announced the mobile service condition. For example, average data rate, or call drop rate, or coverage. So periodically announce these 3 mobile operators with measurement result. So there is a push for the mobile operator, or in other sense, there is to promote the competition among operator. That was good before. But in terms of millimeter wave, if the government start to announce the comparison, there will be big burden for the mobile operators. So that is why the Korean mobile operator hesitated to deploy the network very fast. That is one thing. And second thing is that in Korea, the 3.5 GHz license period is 10 years. But the millimeter wave license of 5 years. So since we allowed the license around 4.5 years ago, the license ending period is approaching. So the mobile operator didn't have sufficient time to deploy network compared with 3.5 years. I think that was one of the reasons. So, I recommend the government to exempt the quality measurement in case of millimeter wave, but that was not accepted. I think these are the conditions, data status in Korea. But we learned the experience, for the past 3 or 4 years. So maybe a coming new mobile operator handling 28 GHz can handle smoothly that kind of problem. This is my guess.
Then this is a question to Mr. Nakamura. You just heard of the Korean situation. Now in Japan, things are going the forward, but the use is still limited. And going back to the presentation by Mr. Ogawa, there could be benefits of 5G, but overwhelming majority of Japanese people do not know the benefit of that because they have not experienced that. When the 5G was introduced, then people drew a picture of the rosy picture was presented. I believe I did the same. But again, these benefits would have been realized with the millimeter wave. So half-wave measure, the 5G would not suffice. So could you tell us a bit about the reason why it was not fulfilled in Japan, Mr. Nakamura?
Hi.
Allow me to again answer in Japanese. This is the comment from the operator, not as the white paper, the ad hoc. As in the case of other operators, in expanding 5G, it is important to make sure that it is cost effective. So we had no other choice but to start with sub-6. This is not only about our company, but also other companies as well. However, having said that, we have to look at the growth of traffic and the potential of the new applications. Then the frequency resources are important. We have millimeter wave, which has been already allocated. So it is high time that we utilize this to the fullest. But again, this is not only related to the expansion of areas, but also we'd like you to read the white paper, and also as has been covered by the presentation by the Mr. Ogawa, we have the area issue. So in order for us to expand the area, well, actually, even if we have the expansion of areas, it is important to increase the number of the terminals. We talked about chicken and egg issue, but again, the increase of the use case is of the essence. Without that, it is impossible to expand the scope of the use of millimeter wave. So telecommunication industry should do our best, but also at the same time, we have to seek for the partnerships with the people from the application field in order to have higher level of utilization of millimeter wave to create a better telecommunication world. So this event is one such effort, and also the white paper we had issued is another the way to do that. There could be many other activities, so it is important to utilize all these tools to raise the momentum to utilize millimeter wave. So that's something we have been working on. And if we are able to do all these, and all these efforts will bear fruit, and then starting next year, we will see the start of the utilization of millimeter wave, and we will see the advent of new applications, and then this will lead to the growth of the businesses of the operators and vendors. Thank you very much. You talked about the chicken and egg issue. Chicken is first, eggs are first. Well, Mr. Ogawa talked about 3 pillars. One is the creation of use cases. Second is the establishment of infrastructure and the base stations. And third is terminals. If we have all these 3, then we are able to have good environment with which to boost the millimeter wave. In the case of Korea, South Korea, you have Samsung, you have terminals enabled for the 5G, you have base stations. But even with this kind of favorable condition, it is very difficult to have the introduction of the millimeter wave. Then in the United States, you have very good situation. Could you tell us a bit about this situation, Mr. Koenig?
All the major manufacturers have millimeter wave, and that includes Apple. So Apple, has it in all but their lowest end phone, and they've had it for the past 3-4 years. And then Samsung has it, Pixel has it, Motorola has it. Motorola actually has competitors' chipset in it. So there is a wide range of phones. So the unfortunate thing is that, and I can't speak for Apple, but Apple doesn't seem to provide those phones outside of the U.S. In the U.S., maybe because of the prevalence of millimeter wave deployments and Verizon's influence, they're able to get that on their network. I would hope that operators around the world and operators in Japan, would have the same influence on Apple, but that doesn't seem to be the case. But I can't speak for Apple. I don't know why, they actually go this route. But that seems to be the missing component in Japan and Australia and other places.
Earlier, you talked about Verizon, and Verizon being a key the institution. Now, in the case of Verizon, they have the frequency allocation, and in the 5G, they had no other choice to get the millimeter wave, and then they applied the pressure to Apple. Is this the case that happened?
So in the initial deployments, Verizon only had millimeter wave. So that really was the 5G deployment in the U.S. So that was the case in the U.S. So when the deployments happened, I think they whatever their relationship with Apple is, I can't speak for Verizon or Apple really, but they were able to get Apple phones with millimeter wave on their network because that really was their 5G launch. I think if that's your only 5G play and you don't have Apple on the network with millimeter wave, then of course it's an issue. So they came to a deal with Apple and made sure that millimeter wave is supported. So now the phone exists. So why that phone is not on international networks is a shame, right? Because the phone does exist. One argument even in the U.S. is that phone is millimeter wave is not everywhere. So then the cost of that phone is being subsidized by everyone else, right? So I live in the New York area, so I get to use millimeter wave, but someone that doesn't live in the New York area, lives somewhere in the middle of the U.S. that doesn't have millimeter wave is still paying for that feature. But in a country like Japan, where there is uniform deployment and future deployment, then that shouldn't be the case, right? People do have access.
So we have 4 operators, and we are selling the Apple devices, and then we can have the all-out pressure to Apple. This is my personal view. Then Mr. Price, could you tell us could you comment on the kind of factors that determining factors or differentiators of the introduction of the millimeter wave or not?
So, taking a step back, we look at America, and America has millimeter wave, and there are devices you can handle that provide that. In Japan, we have millimeter wave, we have mid-band, and we have devices. Sony produces a device. It's not like there's an empty nest here. I think when I think of 5G, when I think of 4G, I think of my mobile phone. That's what 4G solved. When I think of 5G, I think of industry, I think of enterprise use cases, I think of the modernization of society. That doesn't happen on my phone. And I don't think we need to limit the opportunities we see with millimeter wave to the telephone. I think in Japan, there is a huge opportunity with construction, with manufacturing, the ecosystems that are available to leverage the millimeter wave band, which is available, and the sub-6 band, which is available, and to develop ecosystems and to develop technologies that can then emerge globally as millimeter wave starts to become available in other countries. I think is the real opportunity that we have here in this country. China, for instance, is only on mid-band. They will be going to millimeter wave. Is Japan going to be the country that's ahead of the curve there, that's able to vend into that environment when there's massive scale in China and they're hungry for new technology? Will Japan have that ready to go? I think that's the opportunity we see with millimeter wave. Not so much whether I can get a handset here or a handset there, but how can I engage new enterprise? How can I engage new industry? How can I build the virtual world that I can then interact with through glasses, for instance? And the phone then is important as a hub, of course, but other experiences are really what we're driving and striving for in 5G. And millimeter wave is what is going to make those available in a massive scale. In dense areas where we see these experiences coming to light.
はい、それでは少し議論を前に。
Let's move the discussion forward. I think we're starting to understand why there is the delay. So let's talk about how we can promote this and what needs to be done. So creating use cases is the key, is what has been mentioned. Listening to what you are saying, there are some areas where millimeter wave has particular strengths. That's starting to become clear. So entertainment and industrial, like manufacturing, I think it's suited for those applications. And in terms of the way of use, it could be used in public networks, of course, but for private and local 5G, that has higher affinity with millimeter wave. Then standalone, low band, mid band, and millimeter wave, combine all of that, you have to create a system that allows for those aggregation. I think so. Several points were raised. So on that point, I want to ask Mr. Koenig to use this for industrial application. I think it's being discussed in Germany in many ways, and Fraunhofer, I think, is working on this. How should it be applied for industrial use?
Yes, thank you for the question. So let me please also say a little bit of words about the lagging behind. So the question before. So also we see some kind of lagging in industrial deployments. So having 350 licenses in Germany doesn't mean that we have 350 networks, and most of them are proof of concepts. So there's very few companies who use 5G in their daily production routine. And again, also here we have a chicken egg problem. So it's the question of industrial applications. So that means that that's more than just a 5G UE. So it has to be self-contained. It has to be 5G integrated, like having AGVs, forklifts, robots, autonomous robots that come with 5G integrated off the shelf. So that's not yet there. And on the other hand, so the market pull is also not yet picking up. So again, there's a chicken egg problem. And so in 5G ACA, we have done a survey, and it seems like the market pull might come in 2024, 2025, approximately. And with regards to millimeter wave, I see that could potentially help in getting the ball running. And because millimeter wave is actually a USP, and because one reason why 5G has problems in industry is that people keep comparing 5G with Wi-Fi. So especially with Wi-Fi 6 and Wi-Fi 6, of course, has also quite good performance. Well, let's say for few users, not for so many. But nevertheless, that's quite of a burden that we see today. The comparison with Wi-Fi. Now, if you add millimeter wave on top, then that might be a game changer, because millimeter wave will for sure outperform any Wi-Fi setups. And if you, like I proposed, use sub-6 plus Wi-Fi at the same time, then you have a lot of capacity, a lot of opportunities. And that's my opinion. And therefore, I think maturity of Wi-Fi ecosystem for 5G is key to also boost even the sub-6 deployments. Okay, so let's now talk about the potentials. I've hopefully shown that there are quite some applications which are not possible with 5G sub-6 spectrum, where you need very high capacity, which is machine vision, where you need high frame rates and multi-megapixel resolution. That can be done, for instance, in mobile inspection. For instance, with AMRs, autonomous mobile robots, where you have a camera on top of the robot that could for instance, be used to check the quality of a part, or to find the proper place really precisely for pick and place operations, or for joining applications and so on. So everywhere we need high precision, high accuracy, and high speed. That's for me an indication for millimeter wave. Plus, the availability of spectrum is also a large benefit for millimeter wave in industrial applications. So many countries have, let's say, a challenge when it comes to granting sub-6 spectrum for private applications. So the sub-6 spectrum is really crowded today. And speaking for Germany, it's extremely expensive for the mobile network operators. They spend billions of euros to get some chunks of the spectrum. And then it's also scattered around the spectrum, so it's not adjacent blocks. So that's quite a challenge. And therefore, millimeter wave is providing a much more relaxed situation, of course. And that could, let's say, offload the burden on sub-6 spectrum to millimeter wave. And yeah, there are many applications. And you could, if you think about slicing, so slicing is not so much a use case for industry, but if you have enough spectrum, then that could be an opportunity, because you could combine ULLC and eMBB in millimeter wave spectrum easily, much easier than in sub-6. So, and in industry, uplink and uplink latency is key, and therefore sub-6 is also quite good, of course. But when talking about the coexistence of networks, then sub-6 may have some challenges. For instance, in Germany, there's a possibility to apply for private spectrum from in the range of 3.7 to 3.8 gigahertz, or that which we have licensed at our campus, and the spectrum of the Deutsche Telekom, so one of the largest mobile network operators in Germany, they have public spectrum up to 3.7. So they are our spectrum neighbors. So, and therefore, we regulate the TDD spectrum according to the public networks. And that is downlink friendly. And as mentioned, we look very much on uplink. So that's why I think millimeter wave is really a USP for 5G in total.
Thank you for that. So listening to those comments, there was a mentioning of Wi-Fi 6. So unlicensed, high speed. I mean, some people say that Wi-Fi would suffice. So we need to sort out this sort of puzzle. And so as was mentioned, guaranteeing bandwidth or being able to use uplink, I think millimeter wave has strengths. So anyone who has comment, any particular thing that you can only do with millimeter wave, and so that's why we need a millimeter wave. If anyone has such examples, can you share?
Okay, in Korea, even though in public domain, the millimeter wave is still, for the time being, vacant. But in private 5G, we call it EON 5G. There are several applications using millimeter wave. For example, factory or medical applications or amusement park. There is some private 5G usage. And in terms of personal usage, currently in Korea, the public free Wi-Fi is service. In addition to the mobile operators' Wi-Fi service, for example, in bus or subway or public place, the government provide free Wi-Fi service. And currently, the backhaul is provided by LTE. However, we have some plan to replace that backhaul with millimeter wave. For example, in survey, some of the survey, the backhaul is replaced by millimeter wave. And there is some research activities to provide the backhaul for bus using millimeter wave. So that is the current status. And also the XR device, for example, HMD, head-mount device, they require very high traffic, and the millimeter wave is a good solution for that. But still, the HMD device is too expensive for wide deployment. However, the HMD device price is going down, and the more application is available, then millimeter wave link can be a good solution for that service. That's my view. Thank you.
はい、じゃあ小宮さんお願いします。
Yeah, so I think right now the focus has always been the data rate and the throughput, but of course or the latency. But there is more that you can offer in a private deployment. For one, given the millimeter wave's directionality and the ability to multiplex, spatial multiplex in a factory type of environment, you can certainly support, many links of security cameras, of HMD devices, of smartphones, of robots, all in the same spectrum. On top of that, it does enable, given the large bandwidth, positioning, right? So centimeter level positioning, which is also important in a factory use case. And as we look forward, actually that expands into RF sensing as well. And that's something that we've been exploring, using millimeter wave to sense any kind of device-free object in space, which is again important in a industrial environment. So objects that don't have modems in them, but maybe they're blockage or they might disrupt your factory environment, but you can detect them using the same communication network.
Mr. Koiman, you talked about fixed y-axis, FWA. This is the one use case that I believe you talked about this. In the case of Japan, we have the optical the network, so we do not have too much of a FWA. In the United States, you have the optical system and the also FWA. So this is a tool for that. Could you comment on that?
Yeah, so I think first in a place like Japan and Korea, where the fiber network is very dense, much more than the U.S. I think Christopher was saying that there's still a benefit, so maybe I'll let him answer afterwards. But that actually plays into not fixed wireless access, but of course millimeter wave deployments, where there's fiber everywhere. So it's a case for maybe densifying millimeter wave network. In a place like U.S. or in Italy with fast web and or India, fixed wireless access does play a role in the last mile for broadband, because the fiber networks are not that prevalent. Certainly even in the U.S., even a place like the New York metropolitan area, fiber is not that prevalent, and so already fixed wireless access in Boston, for instance, a company called Starry, is very prevalent. It's they provide building to building links and provide the broadband to users. Or in a place like Italy, from village to village. So I think it's a very good use case. Certainly not the only use case, but a very good use case for millimeter wave.
Mr. Price, what's your take on that? So, are there any applications that the millimeter wave would be the only option? You talked about the local, the 5G or 5G. So, are there any applications for which millimeter wave would be the only option?
I think millimeter wave can become the best practical option in a lot of cases. You can always run an optical fiber somewhere, but it's not practical to attach it to a car, for instance. But I think there are many scenarios where millimeter wave and the NR technology provides the types of stringent requirement fulfillments, that's a terrible way of saying that is able to fulfill a number of stringent requirements that other technologies can't. The quality of service capability is embedded and inherent in the way the radio access is managed and scheduled is different than, for instance, Wi-Fi or other technologies. And in that, we can achieve things with millimeter wave that we can't achieve with other technologies. So when I think of modernizing hospitals and having assisted surgery, where you really want to be able to get very, very precise positioning, extremely good high-resolution video, and absolutely uninterrupted services, then something like millimeter wave is the technology of choice. It solves all your problems, and it does so in a consistent and cohesive way. For large manufacturing solutions where absolute guaranteed delivery with very, very tight latency restrictions, 5G technology, NR technologies, and millimeter wave with the high throughput is the best choice in a wireless scenario for that. So I think there are a number of scenarios where millimeter wave is the right choice, is the best choice. But I'm a software guy. In software, we say you can program anything to work. It doesn't have to work well. So you can choose a number of technologies, but finding the best technology that gives you the right price point to achieve a use case is important. And I think I was referring to that with the fixed wireless access. It's in some cases it can be cheaper to use fixed wireless access to deliver to a home than to use the optical fiber. And we see in Australia, in countries like Australia, where people who do have fiber into their home will choose fixed wireless access because it provides them what they need at a better price point. And so it's the consumer that drives, it's the price point that's important there as well.
Thank you so much. Time is running short, so I'd like to go to the final part. In what way are we able to have the higher penetration of millimeter wave? We, as the government or the businesses, what should we do in order to have higher dissemination of the millimeter wave? Mr. Tatebayashi, thank you for waiting. KDDI is in a very unique position. You are providing services for the millimeter wave, and also you are utilizing millimeter wave yourself to come up with a new use case. So you are the true leader of this the initiative. But in the case of the 5G, license fee is incurred, and also infrastructure cost is also negligible. So you have to pay a certain amount of money, and then at the same time you have to consider how you are able to monetize this service. The Ministry of Infrastructure and Telecommunication has a mission to move on to this, but in the past they have been not been very enthusiastic, but now they are thinking of introducing auctions. So could you tell us a bit about how we are able to have a formation with which to promote the utilization of millimeter wave? Nakamura-san, I think we have to start with the environment. And you talked about FWA, but in the case of Japan, this would be difficult to have a penetration. This is not a kind of system or the product that would have a very good acceptance, maybe because of the size or maybe because of the altitude that Japan has. Then in the case of millimeter wave, looking at this from the viewpoint of the businesses or the companies or the people, what are some of the products that would appeal to these people? So probably we have use cases at the moment, and these are, in a way, the disk-sized drills, but maybe it is possible. I think it makes sense to present the samples, which is easy to understand. So in the case of entertainment use cases, maybe you could wear smart glasses and see something. And then in a situation, many people would say that can be realized by sub-6. And then in that situation, you try to come up with something more precise. And then in that situation, you could use crowd leveling. And then in that situation, the thickness of uplink and downlink is important. And then high capacity is needed. Then in that situation, everybody will be able to see photorealistic avatars. So this is a rich experience. That would be a very interesting use case. It is not that the use case itself is interesting enough, but rather with the introduction of that, the service layer it can be seen to many people, and then people would be convinced and come up with something new. So maybe we are 2 or 3 years later than other countries, but maybe we are able to involve these people in the entertainment field and in the industry field. I think it makes sense to come up with new use cases. For that purpose, the generative AI kind of approach is important. I think this will drive the situation at this moment.
Talking about the entertainment example, the avatar in the smart glass, you can generate to your liking, and you can do that with cloud rendering. So avatars that people looking at are all different. So that's possible in industry. If you feed the high resolution video to AI, then you can have a good output, and then millimeter wave will become a necessity in the market. So classification and personalized use case, we will work hard on that, and if carriers will provide that, and then people who understand that will appear in the service layer. I think that will be important for disseminating millimeter wave. So Nakamura-san, I want to ask you as well. Nakamura-san, you're with Docomo. So Docomo is promoting public 5G. I think that's one of your missions. But in your ad hoc committee, as the top of that committee, you have the mission to disseminate 5G nationwide. So you have NTT East and West and NTT Communications in addition to Docomo. So you're also in a position to promote the local 5G as well. So talk about what you can do and talk about what you want the government to do, please. Also, 5G MF. As 5G MF, what needs to be done? So as the 5G MF ad hoc, we will continue to look at the effectiveness of millimeter wave, and we will promote that, not just in our industry, but we will publicize that to various industries, talking about scenarios, create scenarios where millimeter wave can be utilized. Not just limited to millimeter wave, but people in other industries, I think they don't have a good understanding of what 5G is to begin with. So there's private 5G or local 5G. And so applying 5G to various industries, that's being assumed. So there's a lot of talk. But in terms of introduction of 5G, the rate is very low. Dissemination rate is low, even lower for millimeter wave. So I think the first thing to do is to publicize the effectiveness of 5G. How effective is it for various businesses? We have to show how useful it is with 5G and how better it's going to get with millimeter wave. So 5G MF, we, and as a company and the other companies, I think we should focus on publicizing those strengths. Well, we're a member of the 5G ACIA. So 5G ACIA activities are being conducted, and we're discussing with various parties in Japan. And to people in other industries, I think we need to communicate to them the truth about 5G. I think the understanding is insufficient. So let's have people understand 5G better, then show them that you can do even more with millimeter wave. I think that's how we need to publicize this. Also, MIC, Ministry of Internal Affairs and Communications, national government should provide support to expand the coverage area. The kind of funding support is one part of it, but that's just one of the many. So it shouldn't be just that. So a millimeter wave working group has been established by MIC from early this year to try to raise the momentum. So they have been working on this. So to use 5G and then millimeter wave in every industry to create opportunities to stimulate the motivation for that, we ask MIC to create such opportunities, create opportunities for us to appeal the benefits of 5G and the millimeter wave. That would be very nice. So running out of time, but finally, I want to ask each of you, the five, other than Mr. Nakamura, talk about 1 minute each. What needs to be done to disseminate 5G? Anything? Also, Dr. Lee, please.
Yeah, for me, the 5G differentiation with the LTE is that not for the data rate, but for the low latency is more fascinating for me. Of course, the SA network is widely provided, then the more people can utilize. So I think for millimeter wave, the expansion, I think the more application for low latency, for example, the mobile gaming, that can be, we should keep in mind. Thank you.
Mr.
Koiminen, please.
I think one thing, stopping the deployment, especially for millimeter wave, is actually regulatory. Being able to get access to sites. So that's a problem in the U.S. I think it's also a problem in Japan, because I think even repeaters were just allowed to be deployed recently, because I think it'll require small cells and different types of repeaters, and then network control repeaters and RIS in the future. So being able to carefully deploy this will require some regulatory, relaxation, for these.
That's true. Regulation is very important. Mr. Price, please.
Back to basics. Find use cases that will make money. New technology costs a lot to deploy. So let's find use cases and make money. Let's develop ecosystems around those use cases. And let's start to generate revenue and interest, and then we build out from there. So back to what was said at the very beginning, those three things: the ecosystems, the use cases, and then the monetization.
So, Mr. Kenny first, please.
Yes, so thank you. So I think it's clear when looking at millimeter wave for industrial applications, there's a lot of potentials, many exciting use cases which are not possible with other technology. So 5G may provide a unique selling point and may outperform sub-6 at Wi-Fi. And yeah, as mentioned, sub-6 plus millimeter wave will be a perfect setup, I think. But of course, we have to a little bit improve the conditions of coverage, and their risk is highly attractive. And this will add a new class of devices, of equipment, which is really exciting, I think. And yeah, we are eager to work on that and test it on a very early state, and collaborating with many researchers and hopefully also with Japanese researchers on the effect of risk in industry.
はい。じゃあ立林さんお願いします。
はい。
Tatabayashi-san, to repeat, a very easy to understand use case, I think is essential, and robot and head-mounted display and smart glasses, those terminals, there should be millimeter wave compatible ones that should increase, and that would help to increase the application and the use. And so the members here, they should be the central force to promote this. That would be necessary to make up for the delay past several years. So much more I like to ask, but the time has come. Listening to the various comments, I learned a lot, and I think I'm starting to see the future direction. So industrial use, entertainment, and then mobility. I think there's several applications were mentioned. So characteristic of millimeter wave should be harnessed, and good application should be developed around that, and then that would enhance the value of usage and increase the monetized opportunities for industrial. Was it 2016 when Prime Minister Abe was still alive? He has passed away. There was a CEATEC conference in Germany. He went there and met with the Chancellor Merkel. And one agenda was wireless in factories. And so between Japan and Germany, there was a MOU signed. So what was done in a wired manner to do it wireless with reliability secured. But then after that, there was COVID, and Prime Minister Abe resigned, so it really hasn't progressed. But maybe difficult to do the use case just only in Japan or only in Germany. So working together to create the use cases, I think that's necessary. And 5G MF is a great forum for extending that kind of cooperation. So wonderful 6 speakers. Let's give them a big round of applause and end the session. Thank you so much for staying us to the evening.
Thank you very much, Mr. Sekiguchi and all the panel members. Please give them a big hand. Thank you very much. Finally, we'd like to invite Mr. Omura Yoshinori, the 5th Generation Mobile Communication Promotion Forum Secretary General, to say a few words at the closing of this international workshop. Thank you very much for your introduction. I am Omura, Secretary General of the 5th Generation Mobile Communications Promotion Forum. It's about to close the session, so I'd like to be brief. Today in the afternoon, we had the millimeter wave penetration session. That was a very rich and also very fulfilling the session. In the presentations, you talked about the proactive use of AI, and also in the panel discussion, you talked about the possibility of the reversing the trend, and also to enhance the penetration of millimeter wave. And also at the same time, you talked about the monetization of millimeter wave technologies. I'd like to extend my sincerest appreciation to all the panel members. Although millimeter wave has not been widely used in the world, but will be in the near future, there is a lot of room for growth. If the conditions are met, we can expect dramatic business effects in the next few years. As mentioned in Chairman Yoshida's opening remarks, the 5G MF will cease its activities at the end of next year, the end of March next year, and from April, we will evolve into a new forum with the integration with the 6G activity organization, and we were able to have a very good activity with the support and cooperation of many people. I'd like to extend my sincere appreciation to each and every one of you for that. So we look forward to participating in CEATEC 2024 next year with a renewed focus on 6G as our main theme. Finally, I'd like to thank the Ministry of Internal Affairs and Communications and the 5G MF for their support, and also people who supported 5G MF for your support and cooperation in organizing this workshop. I'd also like to express my sincere appreciation to all of you who are participating face-to-face and also participating online. Lastly, after the closing of the session, the moderator will ask you to fill out a survey. So please give us your feedback. With this, I'd like to close this international workshop. Thank you very much. Thank you very much, Mr. Omura. We'd like to extend our sincere appreciation to all the panel members, all the speakers, and all the people who are present here. Lastly, I'd like to ask for the cooperation in filling out the survey. Please use the URL on your smartphone or the chat room to give us your opinions and comments. And we would like to return the simultaneous translation receiver at the exit to the person in charge. With this, we'd like to close this session, the 5G Special Day 5 Latest Trend 2023 International Workshop. Thank you very much.